Good evening. Yeah, we'll continue with the problems. What was the last problem we did? Do you remember that? Last problem. Railway track. Okay. Take down the next question quickly. A student connects a long air core coil of manganese wire. A student connects a long air core coil of manganese wire. Your book back question actually it is 4.58. You can simply copy the text. Question book back question 4.58. Here we have to calculate the value of reactance and the inductance of the coil. Okay, have you copied the questions? Question number 4.58. If you have copied, just raise your hand. Then we will continue with the solution. Yeah? Okay. Take down the data. What is given here? It is connected to a 100 volt DC source. So since it is 100 volt DC, we have to take this EMF. E is equal to 100 volt. Right? And then the current I is equal to 1.5 volt. Sorry, 1.5 ampere. Right? And then when the same coil is connected across the 100 volts 50 hertz AC source. So when it is given as AC source, you have to take this. We know that already the current and EMF of AC source should be taken as IRMS and ERMS. It cannot be taken as it is what we are getting in the DC source. So in case of AC source, we have to take this as ERMS. So ERMS is given as how much is that? 100 volt again. 100 volt, and similarly IRMS is also given as the same which is given here, it is 1 amp. For DC it is 1.5, for AC it is given as 1 amp. And then what is that? The frequency of AC is also given, isn't it? Frequency of AC is taken as nu, this is 50 hertz. Right? 50 hertz. Now what is our aim? To calculate the value of reactance and inductance of the coil. To find out the reactance and inductance, what is that required? We know the formula for reactance and for inductance also, isn't it? Actually, here inductance should be calculated by using the formula, the impedance. The impedance formula we know that, isn't it? So using that impedance formula, we have to calculate the inductance. But to calculate this inductance, we need resistance, right? So first we have to calculate the resistance, and then we can calculate the impedance, and then by using these two we can calculate the inductive reactance, or that is inductance, right? So first three things we have to know. How to calculate the resistance? The resistance can be calculated by using this DC source. R is equal to V by I. Then by using this, the inductance of the coil can be calculated. That is impedance. Impedance is nothing but Z. Z is also something like R only. R is equal to V by I. Same formula. But here, how we are going to calculate, let us see. First to take down how to calculate the resistance. That is, in a DC circuit, what is the resistance? So in the DC circuit, first you take this as in the DC circuit. So what is R? R is equal to resistance is equal to V by I. Here V is nothing but E, and so we have to write it as E by I. So what is E here? It is 100 divided by 1.5. So what is 100 divided by 1.5? We'll have to calculate using the log book. Come on, calculate it. How to find out the value of 100 by 1.5? Take the log value of log 100 log 1.5. Calculate quickly and tell me. Take anti-log and tell me quickly. This is 2.0000. The next one is for 1.5, that is 15 0. It is 0.1761. So we have to subtract it. So it is 9, 9 minus 6 3, 9 minus 7 2, 9 minus 1 8, here 1. So take anti-log. Anti-log of 1.8239. That is equal to 66.67. Right? So this is how we have to calculate the value of the resistance. It is 66.67 ohms. Now we have calculated the value of resistance. The next one is we have to calculate the value of impedance. So take this as rough value. It should have been done at the end. Actually, in your paper also, draw all these things in the rough column. Okay, always do that on the rough column. Never do that in the middle. So that will be. Now we have to calculate impedance, because the formula XL is equal to, that is Z is equal to square root of R square plus Z square. That formula we have to understand. Using that only we are going to calculate. So before that we have to find out the impedance of the coil. Impedance of the coil. That is called Z. So Z value is also similar to that one. It is E by I, but here in this case of AC, we have to take this as effective, that is E RMS by I RMS. Okay, E RMS can be called as E effective. Both are same only. Okay, so I will write it as E effective by I effective, or you can write it as E RMS by I RMS. So how much is that? It is 100 by 1. This is nothing but 100 ohms. So the impedance value is also 100 ohms. Now this Z and R can be interlinked by using this formula. We know that this phasor diagram you remember, I think. Okay, this is XL and this one is R and this is taken as Z. Okay, this is XL. So we can write Z is equal to square root of R square plus XL square. Remember that. I am omitting the value of XC. Since we are talking about only inductance resistance, it should be like this. If it has got a capacitor, it will have XL minus XC whole square. Okay, this value will become XL minus XC. So since only two are there, we are taking this formula. Now we have got Z here, we have got R here. So from this we can find out what is XL. How can you find out XL here? This XL can be written as, so Z square is equal to R square plus XL square, or XL is equal to square root of Z square minus R square. So this formula only I am going to use now. Now from this XL, we know what is XL. What is the value of XL? Formula XL is equal to inductive reactance. What is the formula? What is XL? XL formula என்ன சார்? XC க்கும் XL க்கும் formula சொல்லிருக்கேன் beginningல. UV ஏதாவது சொல்லலாம், தப்பு தப்பா சொன்னாலும் பரவாயில்ல, ஏதாவது ஒரு ஃபார்முலா சொல்லு. தப்பு தப்பா நான் சொல்ல முடியாது, ஒன்னா தப்பா சொல்ல சொன்னேன். Ask Nitya whether she can say. Very bad. Okay, L omega. Okay, XL is equal to L omega and XC is equal to 1 by C omega. இந்த ரெண்டு ஃபார்முலா ஞாபகம் வச்சுக்கோங்க. Inductive reactance and capacitive reactance. The resistance offered in an AC circuit containing capacitor, that is capacitor. Resistance offered by capacitor is called a capacitive reactance. அதே மாதிரி resistance offered by inductor in an AC circuit is called a inductive reactance. நம்மள என்ன கேட்டிருக்காங்கன்னா இப்ப L தான் கண்டுபிடிக்க சொல்லிருக்காங்க. அதனால first XL கண்டுபிடிச்சிட்டு அதுக்கு அப்புறம் என்ன பண்ணலாம், L கண்டுபிடிக்கலாம். Okay, right, now we will find out what is XL. So using that formula, XL is equal to, that is XL is equal to square root of Z square minus R square. So square root of Z square is already we have found out. What is that? 100 square minus 66.67 square whole square. Now we have to take the log for this. Come on. How to take log for this? First you have to take log for 100, that is 100 square. How can you write it as 10 power 4? It can be written as 10 power 4. Okay. There are two ways of doing this. Either you can multiply this and put that, or you can take this as 2 log 100. Similarly 2 log 66.67. Then subtract it, then divided by 2, then anti-log. Somewhat bigger one, but you have to know how to calculate it. You copy this up to this quickly. See here, log 100 square. I can write this as 2 log 100. And similarly, log 66.67 square can be written as 2 log 66.67. Okay, that can be written as 2 into, write this log 100. What is log 100? Yes, 2.0000. Similarly, 66, 67. 1.8240. Okay. Now this implies you have to multiply this first. So you can write this as 4.0000, and this is 2. 3 point. Okay. Now we have to subtract it and then take half of this. Now subtract, because it is subtraction, isn't it? So subtract it. 0, 2, 5, 3, 0. Now this is half of log 100 square minus 66.67 whole square. This is half of 0.3520. You have to divide this by 2. 0.1760. Now we have to take the anti-log. So take anti-log of 1760, how much is that? How much is that? Yes, how much is that? See, if you feel that it is too difficult, you can write like this. See, 100 square is 10,000. Similarly, for 66.67 square, for that you have to calculate like this: log 66.67, then log 66.67. Find out that this is nothing but 1.8240, and this is 1.8240. Now we have to add this. So how much will you get? 3.6480. So for this, take anti-log. So what will you get? Anti-log of this 3.6480. What is that? Take the anti-log for this 6480. If I am asking log, please tell me quickly. Unless otherwise you learn to take this logarithm, you will not be able to solve any problem. It is 4446. Okay. Now this can be written as 10,000 minus 4446. This can be subtracted easily now. So how much will you get? 4555. 5554. Okay. Now for taking square root of 4445, you can write this as log of, that is 4445 power half. That is, you have to take log 4445. So how to find out 4445 log? Find out the log value of 4445. Sorry, 5554. No, I made a mistake here. Correct it as 5554. It is 5554 power half. Take log for this. It is 3 point. Quickly. 55, 54, 55th, fifth column difference, and then fourth difference. 7446. 7446. Okay. Now since it is square root, you have to take this as half log. Half of log 5554. This is nothing but 3.7446 by 2. This 1.8723. You should get like this. This value should be 1.8723. Somewhere there is mistake here. You check it out later. Okay. So now take the antilog for this. 1.8723. Antilog of 8723. 8723. 7447 plus 7452. 7452. So this is the value of XL. 74.52 ohms. This is the value of XL. So you have to get the value like this. Okay. So instead of following this method, you can follow that one. It will be easy for you. So that in each step you are doing that without any mistake. Right. So you have got the value of XL. Now how to find out this L from XL? Now you know XL is equal to L omega. Now omega is equal to how much? What is the value of omega? Is there a formula? Omega formula. Omega is equal to mathematics எத்தனை இங்க போடுற நீ? Omega is equal to என்னன்னா omega. Oh my god. See, omega is nothing but 2 pi nu. Omega is equal to 2 pi nu. Understand? Right. So XL is equal to L into 2 pi nu. From this we can say L is equal to XL by 2 pi nu. So in the formula use பண்ணி என்ன பண்ணலாம்? Inductance கண்டுபிடிக்கலாம். Because XL formula we know the value of XL. இப்பதான் கண்டுபிடிச்சோம். How much is that? 74.52 by 2 into 3.14. What is the value of nu here? From the given data, what is the value of nu? Frequency of AC என்ன கொடுத்திருக்கு? 50, exactly. So write it as 50. Now, you are going to give me the answer for this. Take logarithm, subtract, take antilog and tell me the value quickly. Let us see how you are able to calculate this. Come on. I'll wait for you. Quick. I'll take this one first. Log 2, log 3.14, then log 50. First take this and add that first. $20, 3010, 31, 4, 4369, 4969, 31, 4, 4969, yeah. Then 50, 1.6990. Now you have to add this. .4969. Now in this you have to subtract this value of log 74.52. I've taken the wrong way. The numerator is there, no? Have you got it? Don't look at the board. I asked you to work out quickly. Before I complete, you should be able to do that. Now take antilog of 54. Yeah, got it? Nitya, tell me, what is the value of the inductance? Get the mic and tell me quickly. Have you got the answer or not? Say yes or no. Tell me what is the value? Okay, tell me the log value of the numerator. Log value of the numerator. I told you not to do like this. How did you multiply the numerator value? It is only 74.52, no? Log value of 74.52. What is the value? It seems, then how did you get the answer? Manually. It is foolishness to do like this. I told you to do the log value and find out. And you are trying to cheat me. How will you learn then? You don't require any textbook for that. You can get the book from somebody else. Two boys are there, they would have got 2 books. You can borrow one and do that. You are coming for physics class without textbook. And tomorrow onwards, I think before you enter the classroom, I will ask that sir to check whether you have got book or not. Then only you have to be allowed. Yesterday you didn't have paper, today you don't have book, tomorrow you will not be there. Day by day you are deteriorating. Yuvraj, please copy that. I have already done it for you. You can check it out. Make it fast. You have to take the log value like this for the denominator 2, 3.14 and 50. Add that, keep it as it is. Then take the log for the numerator, keep it here. Take the denominator value here, subtract it. Then anti-log for this. So you will get 0.2373. And without doing that, Nitya has done that. It's quite amazing. Quick, quick, quick. I used to solve all the problems from the textbook and the book back questions in my class actually. But since you are all seem to be very nervous in using this logarithm book, I am taking only very few questions. And for that too, if you are hesitating to do the sum, it will be very difficult for you to attempt and get 100%. Quick, quick, make it fast and take the next question. Next question is related to transformers. That's very easy for you. Yuvraj, if you have got 2 books with you, you can give one to Nitya. Now I'll come to know whether all the three have got the book or not. Do you have the book with you, Yuvraj? Why? Who has not brought the book? அப்படி சொல்லி சொல்றான் அவன் மகேஷ். நல்லா தெரியுது. we are very good friends it seems. பயங்கரமா விட்டுக்கிட்டு பாவம். I know that Magesh has not brought the book. Don't do like this. For every class you have to come with book. Otherwise how will you know that? It's disappointing for me. Very bad. Take down the next question at least. The primary of the transformer, quickly. The primary of a transformer has $400 turns. While the secondary has 2,000 turns. Now Nitya, tell me, is this a step down transformer or step up transformer? Are you sure? Sir, ரெண்டு தானே சார் ஆன்சர் ஏதாவது சொல்லி ஓபன் சொன்னீங்க. Tell me. I know that. ரெண்டு சாய்ஸ் கொடுத்துட்டு ஏதாவது ஒன்று கேட்டா என்ன பண்ணுவாங்க, ஏதாவது சொல்லி வைப்போம். அப்படின்னா பை ஃப்ளூக் ஏதாவது ஒன்று ஆன்சர் ரெடி ஆயிடும் அப்படின்னு. சி செகண்டரியில நம்பர் அதிகமா இருந்தா இட்ஸ் அ ஸ்டெப் அப் டிரான்ஸ்ஃபார்மர். பிரைமரியில நம்பர் ஆஃப் டர்ன்ஸ் அதிகமா இருந்தா இது ஸ்டெப் டவுன் டிரான்ஸ்ஃபார்மர். ஞாபகம் வச்சுக்கணும். ஓகே, பிரைமரியில நம்பர் ஆஃப் டர்ன்ஸ் அதிகமா இருந்தா, செகண்டரியில கம்மியா இருந்தா அது ஸ்டெப் டவுன். பிரைமரியில கம்மியா இருந்து செகண்டரியில அதிகமா இருந்தா அது ஸ்டெப் அப் டிரான்ஸ்ஃபார்மர். ரைட். Now continue the question. If the power output from the secondary at 1100 volt is 12.1 kilowatts is 12.1 kW kilowatt. Calculate the primary voltage. Full stop. If the resistance of primary is 0.2 ohms and that of secondary is 2 ohms. And the efficiency of the transformer is 90%. Now calculate heat loss in the primary coil and heat loss in the secondary coil. Now, before taking data, I'll ask one question, whether you remember that or not. Let's see. The Joule's law of heating, third lesson la beginning la paathirukom illaya, adu formula nyama iruka? H is equal to heat developed when a current is flowing through a conductor is directly proportional to avlam padichirukom, or law, Joule's law of heating. adula H is equal to enna formula nyama iruka? சார் அது போன மாசம் சார். அதே மாதிரி டிரான்ஸ்ஃபார்மர் பத்தி படிக்கும்போது we have calculated கரண்ட் அதிகமா இருந்தா எவ்வளவு ஹீட் லாஸ் இருக்கும், கரண்ட் கம்மியா இருந்தா எவ்வளவு ஹீட் லாஸ் எடுக்கும் பார்த்திருக்கோம். அந்த எக்ஸாம்பிள் பார்க்கும்போது அது கூட ஃபார்முலா யூஸ் பண்ணுவோம். H is equal to எவ்வளவு அப்படின்னு, heat generated in the transformer due to Joule's law of heating அப்படினு பார்த்தோம். அந்த H is equal என்ன ஃபார்முலா ஞாபகம் இருக்கா? நித்யா ஏதாவது சொல்லணும், மைக் ஒன்டேனா இருக்கு. மைக் ஒன்டா இருக்குன்னா எடுத்து மைக் எடுத்து கொடுக்க வரேன், நீ இருந்தா தானே பதில் சொல்லணும் அப்படின்னு. யுவராஜ், get the mic. I thought that you are going to answer, but you are trying to give away the mic. Very good tactics. Okay, see, H is equal to I square R. இதான் நம்ம யூஸ் பண்ண போற ஃபார்முலா. ஓகே, இல்ல ரெசிஸ்டன்ஸ் நமக்கு ஏற்கனவே கொடுத்துட்டாங்க. நம்ம என்ன கண்டுபிடிக்கணும், பிரைமரி காயிலையும் செகண்டரி காயிலையும் இருக்க கரண்ட் கண்டுபிடிச்சா என்ன பண்ணலாம், இதை கண்டுபிடிச்சிடலாம். IP and IS. இப்ப IP and IS கண்டுபிடிக்கதான் என்ன கொடுத்துருக்காங்க க்ளூ. யுவராஜ், நமக்கு எதுக்கு சார் இதெல்லாம், இந்த ப்ராப்ளமே வேணாம் சார் அப்படின்றான். am I right? யுவராஜ் கரெக்ட் தானே? கரெக்டா இல்லையா? பண்ணலாமா? ப்ராப்ளம் பண்ணலாம் இல்லையா? சிம்பிள் ப்ராப்ளம் சொல்லி. ஓகே, சோ அதுக்கு தான் எஃபிஷியன்சி கொடுத்திருக்கு. இன்புட் பவர் பை அவுட்புட் பவர் பை இன்புட் பவர். அதை யூஸ் பண்ணி என்ன பண்ணலாம், நம்ம கரண்ட் கண்டுபிடிச்சிடலாம். இப்ப அதுல இன்னொரு ஃபார்முலா நம்ம யூஸ் பண்ண போறோம்னா, P is equal to இந்த பவர் is equal to VI ஞாபகம் இருக்கு இல்லையா, V into I. அதுதான் என்ன சொல்லுவீங்க, E into I அப்படின்னு சொல்லுவோம். if it is primary coilனாக்கா P is equal to IS ES அப்படின்னு சொல்லுவாங்க. ஓகே, செகண்டரினா IS ES, பிரைமரினா IP EP அப்படின்னு. ஓகே, அந்த ஃபார்முலா யூஸ் பண்ணி என்ன பண்ண போறோம் நம்ம, we are going to find out the data. Okay, take the data first. We'll take one by one. What is the primary coil? Number of turns in primary coil is NP. It is taken as 400. And similarly in the secondary coil it is 2000. And then voltage, EMF in the primary coil is, EMF in the secondary coil is 1100 volts. Okay, then similarly what is given as power output is given. Power output power is given as 12.1 kW, kilowatts. And then resistance of primary coil is given, RP is given, and resistance of secondary coil is also given. RP is 0.2 ohms and RS is 2 ohms. And efficiency of the transformer eta is given, it is 90%. So this is the given data. Now what is our aim? To find out IP and IS. So if you know this IS and IP, then we can calculate the power loss. Now let us see how to calculate the IP and IS. Now output power is given. Already I told you output power is nothing but this output power you can write, use this formula, output power is equal to ES IS. ES IS. So this is output power. இப்போ இந்த ஃபார்முலா வச்சு என்ன பண்ணலாமோ IS கண்டுபிடிக்கலாம். ஆனா இதுக்கு என்ன வேணும்? We have to know right. Now take the solution. How to calculate that? See that? While you are studying about the transformer, I told you there is one important formula which is relating the transformer ratio K. Clear? Do you remember that formula? எதை கேட்டா I don't know sir, don't know sir, you tell me sir அப்படினா என்ன பண்றது? See, EP by NP, EMF per turn will be equal to EMF per turn in the secondary coil, that is ES by NS. Okay? இதுல see, NP is given, ES is given, NS is given. So all the three are given. Using this we can find out EP. So what is EP now? EP is equal to ES by NS into NP. So இதுல இருந்து ES substitute பண்ணுங்க. ES is 1100, NS is 2000, NP is 400. So calculate 0, 0, 0, 0. Then this can be written as one more 0 is there. So this can be written as 2. So 2 11s are 2200. That is 220 volts. This is EP, that is EMF in the primary coil. Okay. Next, how to find out the power output? I told you already. What is that? ESIS. Okay. So using this ESIS, ES is there. Now how to find out this IS? So using this value, we have to find out the value of IS. Okay. So use that now. Power, output power is equal to ES IS. From this we can find out output power is given already. How much is that? 12.1 kilowatt. That is 12.1 into 1000. Kilowatts means 1000 is equal to ES is already given. That is 1100 into IS. From this we can find out what is IS. IS is 12.1 into 1000 all divided by 1100. Okay. So calculate it now. Simply you can just strike it out. So this is 11 11s are 121. That is, how much is that? 1.1 into 10. That is, you can strike out this and write it as 10. That is 1.10 is 11 amps. So IS is 11 ampere. right? So IS we have found out. Now for this formula we have got I and E we have to find out. So for primary and both secondary. So we have found out the for secondary. Similarly we have to find out the primary current, that is IP. Okay. Have you copied this part? Shall I have this one? Say yes or no. Okay. Now, efficiency eta we know. Eta is nothing but output power by input power. Output power by input power. So this output power is nothing but ES IS by input power is EP into IP. But here in the textbook it is given as the output power is already given. How much is that? That is 12.1 kilowatts. So that we have taken already. Output power is taken already. And we have to find out the input power. And to find out the input power, we can use this. Since eta is given as 90%, I will write it as 90 by 100 by, this is nothing but input power. Okay. Now from this I can cross multiply it. Now I can say input power is equal to 12.1 into 1000 by this 90 by 100 will become this is taken here. So if it comes here 90 by 100 will become 100 by 90. So I will write this as 100 by 90. Okay. Now how much is that? Calculated quickly. Now what is our aim actually? We have calculated already IS. Now our aim is to find out IP. But that input power is nothing but I have taken out EP into IP, isn't it? So in place of this one you can write as it is EP into IP. And EP already we have found out. I am substituting this value here. So 220 into IP is equal to this one, 12.1 into 1000 into 100 by 90. Now from this IP is equal to 12.1 into 1000 into 100 by 90 into 220. Now calculate it quickly. You can cancel the zeros, 2 zeros here. Right? Now remaining, this can be written as 12100 by 198. Can you find out the answer for this by using logarithm? Take log for this, subtract, and then take anti-log. So if you calculate, you will get 61.12 ampere. So we have got both IP and IS. So using this and using this formula, you can calculate the heat generated in the primary coil and the secondary coil. Heat loss in the primary coil, first point. Heat loss in the primary coil is equal to equally, actually I square r, I can write this as primary means IP square r. So IP is already found out. We have got 61.12. So it is 61.12 into 61.12 into resistance of the primary coil is, you know that in the beginning it is given 0.2. Now you have to take the log for this. Log 61.12, log 61.12, and then log 0.2. 1 point is bar 1 point. So 61.12, if you take log, it is 7861, 1.7861. Similarly, 20, 3010. Now you have to add this. 32, 2.8732. I have to take the anti-log of 2.8732. It is 7467. Since it is 2 points, I have to write it as 746.7. Heat is in terms of joules. Joules or watt? In terms of watt. So write it as watt. (747). Similarly, heat loss in the secondary coil. Make it fast. Calculate the similar to that. In place of IP, you put it as IS and find out. Heat loss in the secondary coil is I S square R. IS we have got already 11 into 11 into resistance of the secondary coil is, I think, 2 ohms. So it is 121 into 2. So 242. 242 watts. So these are the 2 points we are asked to find out. See, I want you to bring the textbook for every class. Okay? Otherwise, it's very difficult. Unless you learn to solve this problems using logarithm book, in the practical definitely you will suffer. Of course, practically we've got a calculator. The board exams will be very easy for you if you understand this. Okay? So in the next class, don't forget to bring the textbook. We'll meet in the next class. And before that, I want to know whether shall we proceed with 5th lesson, or I just want to focus on 8th lesson, nuclear physics, which is very important and also easy for you because it is something related to theoretical part. There is no big derivations involved. So I feel that we will go for 8th lesson first. Okay, then we'll come back if it is required. Tell me, which lesson are they teaching in your school? Yuvraj? 10th lesson, very good. Next, Magesh also same, no? For Nitya. Okay, almost finished, but still you do not know many important things from previous lessons. Okay, let us see. Right, you can go now. We'll meet tomorrow. Thank you.